This is week one of programming with C++, and today we are going to be looking at a basic or simple introduction to the C++ programming language. Now, the objectives of today's video, as I mentioned earlier on, we are only going to talk about the basics of the C++ language, why we should, you know, learn it. There are different between C and C++, object-oriented concepts of C++, and all that. So let's get right into it. So, um, first of all, C++, we need to know how it came about as a programming language. So the C++ was developed by John John Shostrup in 1979 and was initially known as C with classes. The name C++ was introduced by Riscmasiti in 1983, and this was commercially released in 1985 and has undergone standardization by the ANSI ISO since 1998. The evolution C++ built upon the C programming language, adding features that support object-oriented programming. So why should we use C++? We now know the key things. Visual Shashu created C++, but it was formerly known as C with classes, and Rick Masiti, coined it as C++ in 1983. So we now know how C++ came to be. Now, why should we use C++? Well, first of all, it is very efficient. So the efficiency of C++ is close to machine level programming, making it suitable for system level applications and also object-oriented programming. Since C++ supports object-oriented programming or object-oriented programming principles, it allows for better organization and management of our code. And also, it is a compiled language. C++ is compiled, which generally, results in faster execution compared to interpreted languages. And also, the portability of C++. Programs written in C++ can run on various platforms with minimal changes. So these are a few reasons why we need to use C++. Let's move on to object-oriented programming. First of all, what is object-oriented programming? Object-oriented programming is a programming language that implements object-oriented design. It is a programming language that you know implements object-oriented design. So any programming language that uses or implements object-oriented design is an object-oriented programming or object-oriented programming language. Um, let's move on to the fundamentals of object-oriented programming. The fundamentals of object-oriented programming. What is object-oriented programming really made up of? So we have data abstraction, data encapsulation, inheritance, and polymorphism. We will talk about each one of these. So with data abstraction, it deals with the creation of classes to describe objects. It deals with the creation of classes to describe objects. For encapsulation, it deals with the restricting access to certain components of an object, ensuring that the internal state of the object can only be modified through well-defined interfaces. So basically, it's like some kind of controlled access to object data. It's kind of security, feature or controlled access feature for object data or to object data. So that way, your code is not easily, you know, accessed by anyone. And we move on to inheritance. Inheritance simply means, or inheritance is a mechanism that allows a new class to inherit properties and behaviors from an existing class. Yes, so as a mechanism that allows a new class. By new class, we mean derived class, right? So it allows and a derived class to inherit properties and behaviors from an existing class. Also, the main purpose of inheritance is for code reuse. Yes, since it allows a new or a derived class to inherit properties or behaviors from an existing class, it paves way for code reuse. Polymorphism is also the ability to present the same interface for different underlying data types, allowing for flexibility in code execution. That is polymorphism. So polymorphism paves way for flexibility in code execution since it allows for the same interface to be used across different underlying data types. Now let's move on to a basic C++ program. This is the structure of a basic C++ program. Let me quickly write a code for it as we see here. So this is the structure of a basic C++ program. First have our preprocessor include, then IO stream. Sorry about that. Space std main 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 introduce this. Yes, our brackets. We move down, introduce our curly braces, and we have the freedom to type anything we want, but just not anything we want. So we can simply start off by just prompting our console to print out a simple hello message. So see out line, we terminate it, can run this code. Oh, we misspelled the include. Okay, so we can go ahead to run this code. Let's correct these errors here. Let's correct these errors first. Okay, can go ahead to run this code. So as you can see, hello. So this is a basic C++ program. We just printed out hello. Now let's move on to the next chapter. So processing a C++ program. Processing a C++ program. So it's very simple. There's the editing phase, the pre-processing phase, the compiling phase, the linking phase, the loading phase, the execution phase. So we take each of them one by one. So the editing phase writes the source code using a text editor, right? The editing phase, that's when I write the code down using the text editor. Like the one I used was code blocks. We have other text editors you can use, Visual Studio Code and all that. And then from the editing phase, move on to the pre-processing phase. So the pre-processing phase handles preprocessor directives. That is the line starting with hashtag. Let me take you back. This is a preprocessor. This hashtag include we have. Let me highlight it for you to see. This is a preprocessor, right? So the preprocessing phase handles the preprocessor directives, which prepares the code for compilation. Now move on to the next phase. That's the compiling phase. The compiling phase, or in the compiling phase, the compiler checks the code for syntax errors. Mind you, these text editors uh, used for C++, they have compilers. Some of them you'd have to install a compiler, but the one I use right now, CodeBlocks, has already has a compiler inbuilt. So the compiler checks the code for syntax errors and translates it into machine code. And then after that, the next phase is the linking phase. The linker combines the object code with libraries and other resources to create an executable file. Then move on to the loading phase as well. So after the linker does its job, the loader places the executable program into the computer's memory for execution. Then, last but not the least, the execution phase. Over here, we all know what happens. The program runs, performing a task defined in the code. Let's move on to processes and threads. Processes and threads. Let's see. Processes. Okay, processes. Now, for processes and threads, we need to define what they are. So, a process is a program in execution, which includes the program code and its current activity. So, each process operates independently. That is a process. Whereas a thread is a smaller unit of execution within a process. A thread is a smaller unit of execution within a process. Multiple threads can run concurrently within a single process. Since a thread is a smaller unit of execution within a process, so we can have multiple threads running in a single process, allowing for efficient multitasking. So basically, that is it for the introduction to C++. That is basically all what we are or all what we will discuss today for week one. See you in the next week or see you on the next week.